Before you start this question, you should know that proof something is a very strict requirement. You need to give a correct reason and also the correct proof. If you do not state clearly which angle you're talking about, it's a chance that you get 0 marks here. And then from this graph, they tell you that ABCD is square. So it's a very important thing to remember this is square. After that, we know that BG parallel EC. So BG here are parallel to EC here. At the same time, CG also parallel to DB. We have to prove the triangle BCG this direction are congruent to BCF this direction. So before we start, we should set up the strategy first. First, we already know that there is a pair of lines which is common, so they have the same length. After that, we know this angle is equal to this angle. It's because of alternate angle. Similar reason, we can also say that this angle is equal to this angle because of alternate angle of our parallel lines. Then we can use the evidence is SAS to prove that two triangles are congruent. To write down the step, we first write down BC is equal to BC. The reason is common. If you write down given, then you will lose 1 mark already because it's not the correct reason. After that, about the right angle, angle GBC is equal to angle BCF. The reason is alternate angles. BG parallel CF. And then we can also write down the blue angle now. Angle FBC is equal to angle BCG. The reason are the same, alternate angles. This time is because of BF parallel to CG. That's why triangle BCG congruent to triangle CBF. The reason is ASA. If you can prove that clearly like this, then you can get all 2 marks. Reasons here it seems is easier than before. And then in part A2, they ask us to prove that triangle BCF are similar to triangle DEF. The easiest method to prove that they are similar are using AAA, and it's the only way here. And then first, the vertically opposite angles are the same. Second, because AD are parallel to BC, that's why we find a C shape, we find out this angle is equal to angle FCB, and similar reason, we know the last angle are the same because of alternate angle. So we are now going to write down the reason. First, angle BFC is equal to angle EFD. The reason is called vertically opposite angles. After that, since AD are parallel to BC, the reason is the property of square. Therefore, we know 2 findings. The first finding is angle FED. The green angle is equal to angle BCF. Alternate angles, AD parallel BC. Also, the red angle, angle EDF, equal to angle FBC. Alternate angles, AD parallel BC. Finally, you can write down your conclusion. Therefore, triangle BCF similar to triangle DEF. The reason is AAA. This is a very straightforward question and not difficult, but it's really difficult to get full marks here because we have really strict requirement in proving something in geometry. Part B, they say their two angles are the same, which are angle BCF and also angle BGC here are the same. And then they say let the length BC be L. And then we have to find out DF in terms of L. This kind of question is really obvious that they are related to part A. Even you don't know how to prove that, you should know that we assume this one is true, and then the following property. For example, for congruence, every length and also every corresponding angles are the same. For similar shape, we know that they have a similar ratio, length ratio. So, by looking at this, because they mention about this angle, so we would like to find out is there any related angle. This is from the congruent triangle that we proved in A1. So angle at C should equal to angle at B. They are corresponding angle. So that's why this one are the same. Similar reason. Point G refer to point F. So that's why angle at point F and angle at point G are exactly the same. They try to tell you that this is isosceles triangle by giving you this. So this section is also L. And then our target is to get EF. So we want to know how long is this section. To do so, we can find out the diagonal, the length, and then we subtract L, we can get our target here. If we consider the triangle, this triangle, and I copy it outside, we have L and L, and for the angle between diagonal and edges is 45 degrees. So that's why this will be square root 2 L. And then after that, we minus 1 L. We know our target is square root 2 and then minus 1 time of L. This is our answer. And then we are going to write it down the solution. First, state clearly that we know that angle BCF is equal to angle CBG. At the same time, angle BGC is equal to angle BFC. Therefore, we know these two angles are the same. Angle BFC is equal to angle BCF. Again, don't write down any reason. The reason for these two is corresponding angles, congruent triangle. This one also. And then we can make a conclusion that BF is equal to BC equal to L. The reason is side opposite angles. And then we start calculating BD. BC square and then plus DC square is equal to BD square. So L square plus L square equal to BD square. BD is equal to square root 2 times of L. That's why our target DF is equal to BD minus BF is equal to square root 2L minus L. Extract common factor, that means square root 2 minus 1 times of L. This is our answer in part B1. In the final part of this question, they ask us to compare AE and also DF. From this moment, I have no idea what to do. But again, we are going to make good use of the result of part A. It's very obvious that we are going to consider a pair of similar triangle here. So to find out a related length, which is DE, and then I try to draw out two similar triangles. The first triangle is the bigger one, BFC, and then which is similar to our smaller flipped triangle. Point B is referred to alternate angle point D. So this is D, this is F, and also point E refer to point C. And then we write down the length that we know. We know that BF is L, BC also. So therefore DF is square root 2 minus 1 time of L, DE also. So because of this reason, we already know that this is square root 2 minus 1 time of L. And then don't forget the whole length here is L. That's why we use 1 time minus square root 2 minus 1. Then we get AE already. So we can compare with EF afterwards. That's the strategy. And then we make our decision. We are going to write that down. First, since triangle BCF are similar to triangle DEF. The reason is proved, but don't write it down. And then that's why we know that BF to DF, this length to this length should equal to this length to this length, BC to DE. Then we write down the values except DE. Therefore, DE is equal to L and then times square root 2 minus 1 time of L divided by L. DE is square root 2 minus 1 L also. A very straightforward explanation is like this because this triangle is isosceles triangle. So its similar triangle should also isosceles triangle. Afterward, our target is compare AE. So we write down, therefore AE is equal to L minus DE, which is L minus square root 2 minus 1 time of L. Negative 1 times negative, we got positive L. So this is 2 minus square root 2 times of L. This is AE. It's approximately 0.58578 something L. Then we compare with another line, DF. DF is equal to square root 2 minus 1 time of L, which is 0.41421 something L. So it's obviously smaller than AE. Therefore, AE is larger than DF, and we agree the statement.